All right, this is test review for logarithms and exponential functions. So let's start with number one. The key to doing number one is to identify that we've got a -1 here on the outside. So that's going to shift the graph down 1 unit. So we're going to kind of keep that in the back of our mind and go ahead and put this in your graphing calculator. So go to y equals and type in the problem, -3 raised to the x minus 1. Hit graph, we'll put that in there. If you don't get this exact picture, press zoom 6 in your calculator and you should get this picture. But basically what this picture tells us is there's a horizontal asymptote using the shift down 1 rule, and the picture helps us realize that the horizontal asymptote's at y equals -1. So that's the answer to letter C. This, of course, is a horizontal asymptote. Next, what you want to do is hit second graph, because the directions say to graph at least 4 points. So I see 4 points there. I can easily graph, starting at x equals -2 and stopping at x equals 1. I'm going to graph those 5 points. So we prefer whole number points, but obviously there's only so many whole number points we can fit on this graph. So -2, -1.1, we're just going to estimate, -1, -1.3. The others we can get a little more exact. 0, -2 goes here, 1, -4, and there's your 4 points. We don't need this fifth point, 2, -10, just for 4 points. 2, -10 is too hard to graph anyway on this tiny grid. So there's your graph. It never touches the horizontal asymptote, but gets really close. The domain, of course, is all real numbers because this graph goes left and right infinitely. The range is everything less than -1 because this graph never gets past the horizontal asymptote. It stays below that horizontal asymptote, so that's why its y is less than -1. Lastly, it says describe the transformation of the parent. This is a shift down 1 unit, and the negative sign out front reflects this across the x-axis. All right, so there is written a little bit neater there for number one. All right, number two, the +1 on the outside shifts this graph up 1, so that's going to help us come up with horizontal asymptote. The +1 on the inside is going to shift this graph left 1. So right ahead, let's go ahead and write the transformation for this problem. So there it is, left 1 unit and up 1 unit. And then we can go and put this in y equals 2 raised to the x plus 1 plus 1. Graph it. There's your picture. Again, your horizontal asymptote is going to be at y equals 1. And pick 4 points, 4 easy points to graph. Looks like you got 4 right there, starting at x equals -2, going to x equals 1. You don't have to write out the points, just graph them. So -2, 1.5 goes here. -1, +2, 0, 3, and 1, 5. The domain, again, is all real numbers. It goes left and right infinitely. The range this time is greater than, because it exists above the horizontal asymptote, greater than 1. All right, so that's the first objective. All right, objective number 2, converting from logarithm to exponential function form. So log form looks like this. You need to memorize it. Exponential form looks like this. We're going to convert back and forth from these two forms. So number 2 here gives us a problem, obviously in log form. So this is in that form. Our answer we want to write in that form. So basically all we're doing is rearranging the variables, figure out what y is, what b is, what x is. A lot of different ways to do this, but the shortcut is essentially this, is you take the little number b and you raise it to the 4th power, and it's equal to whatever's left over. So it's equal to 81. And this one should be easy to verify in the calculator. If you type in 3 raised to the 4th, it gives you 81. So some of these you can easily verify in the calculator, see if they're correct. So that's your answer for number 2. Number 3 is there's no log in the problem, so that must mean number 3 is in exponential form. So this problem is in this form. So that means our goal is to convert it to log form. Well, the base, as you can see, is the number that's always being raised to some power. So look in this problem, you see 5 is the number that's being raised to a power. So 5 is your base, just written as a subscript there. So log base 5. And then the next thing is to check our exponent, our x. So our x in this problem is -2. So notice where it goes in logarithm form. It goes on the other side of the equal sign. So I'll put the -2 here. The only other number we have left in this problem is 1/25. So process of elimination, that's our answer. And we can easily check and go backwards the other way by taking the base, raising it to the negative power, and it should equal 1/25. And in fact, that's exactly what's happening in this problem. It's 5 raised to the negative 2nd power equals 1/25. Number 4 is in log form, so convert to exponential form. Take the base, in this case it's just a variable, raise it to everything on the other side, so it's b raised to the x minus 1 power equals whatever's left over. And finally, number 5, 5 is in exponential form, so that means right off the bat we know we're going to convert it to log form. The base is this number being raised to a power. The power it's being raised to goes over here. So 3 raised to the x, that means the other number 55 goes right here. 3 raised to the x does give you 55, so that's a quick way to check to see if you've done it correctly. You don't need those arrows in your answer. All right, number 6 through 8, we're expanding the expression. So there's the basic 3 properties you need to know for these problems. A Cliff Notes version, multiplication expands to addition. Division, misspelled division. Division expands to subtraction. And then this third log property, no real easy way to explain this in words, but all that really happens is this number that's in the exponent slot. Well, if I don't quit moving, this number right here just moves to the front of the logarithm. So letter C, you notice you have one logarithm, so that means we're expanding this to multiple logarithms. We're multiplying x and y to the third. So again, multiplication expands to addition. So our first step here in this problem is to rewrite this as log base bx plus log base b y to the third. But it's not quite complete, because then we can do the third log property and move this exponent to the front of its own personal logarithm. So our answer to this first problem is log base bx plus 3 times log base b y. So right now we're just expanding that one logarithm. Number 7, this time you're multiplying 3 things, 12x and y. So that means if we're expanding this, we're going to expand it to 3 different logarithms. So multiplication expands to addition. So this is log base 8 12 plus log base 8x plus log base 8 y. And that's your answer. No exponents, so no additional steps there. Number 8, we're doing a couple things. We're dividing x squared by 3y. So that converts to subtraction. So that's log x squared minus log 3 times y. But now this second logarithm, multiplication, converts to addition. So we can rewrite log 3 times y as log 3 plus log y. It's all in parentheses because remember this subtraction sign comes down and we're subtracting everything on the right side. So that means you have to have the parentheses around the log 3 plus log y. And then log x squared, this number right here just moves to the front. So this ultimately is your answer. So right over there in the answer blank, notice there's no base on this problem, so there's an assumed base of 10. You do not have to write it, but you can. It wouldn't be incorrect. On the next set of problems, we are condensing the expressions. So that means they're going to give us multiple logarithms. We want to write it as a single logarithm expression. So number 9, we're doing a couple of different things. Inside the parentheses, we're adding 2 logarithms. So we know that addition converts to multiplication the other direction. So this just becomes log base b 3 times x. But then we're subtracting 2 logarithms. What's left over? So of course we know subtraction converts to division. So the number with the first logarithm goes at the top of the fraction. 3x goes at the bottom of the fraction, log base b. So again, we're condensing. Our answer should have just one single logarithm. Same thing on number 10. This time, we're subtracting. So we know subtracting converts to division. But first off, that number out front, we can move to the exponent slot. So this becomes log base 10, there's no base, x to the 5th over y. I encourage you to pause the video, try some of these on your own. 11, we're doing a couple of things. So first, let's go left to right. There's no parentheses, it doesn't matter. So we want to combine those two. Addition converts to multiplication. And then we're also going to move the 2 to the exponent slot of x and the 3 to the exponent slot of y. And while we're at it, let's move the 4 to the exponent slot of z. And then subtraction just converts to division. Number 3, you got to be careful on number 3. So this is an addition problem, so we are going to multiply, but first let's move the 3 and the 5 to the exponent slots. Now we're cubing not just x, but everything that's already there in front of the logarithm. So it's log 5x raised to the 3rd power, and we're going to multiply by that. We're going to go ahead and just change the addition to multiplication. 2x raised to the 5th power. So we can obviously multiply these a little bit. So put 5 raised to the 3rd in your calculator if you don't know what it is. 5 raised to the 3rd is 125. So this is 125 x to the 3rd multiplied by 2 to the 5th. So 2 raised to the 5th power is 32. And we can complete this by multiplying the coefficients, 125, 32. So that's 4,000. So our complete answer is log base 10, 4,000 x to the 8th, because when we multiply variables, you add the exponents. And then last one, number 13, no exponents to move. So this is a straight addition to multiplication problem. So it's log base 2, and we're multiplying 2x minus 9 times 2x plus 9. You're multiplying 2 binomials, so that means you're going to use the box method to multiply 2x minus 9 times 2x plus 9. Key is recognizing that you have to use box. The box in itself is not a problem for most of you guys. Notice those middle terms cancel out. So our answer to this problem is log base 2 4x squared minus 81. Those are conjugates, so that's why everything canceled out for this problem. All right, then finally, for this video, compound interest formula. This really is just inserting numbers into the formula that's given to you right here. So question A says, find the balance of your account if the interest is compounded annually. So a few key things here. P is the initial investment. So they're initially investing $7,200 in this problem. So that's your P variable. Our T variable is the time, the number of years, usually, how long we're investing. So T equals 11. R is the interest rates divided by 100. So R is 12.5 divided by 100, which you can just put in the calculator. So R is 0.125. N is really the only thing that changes in these problems. And that's the number of times the account is compounded. So this one's compounded annually, so that means it's compounded once a year. The only difference in letter B, they say it's compounded monthly, so it is going to be 12 for that problem. So we're solving for A for both these problems, so you're just going to put it in your calculator, exactly like it looks. So 26,303. And 30 cents. And again, same exact thing for this other problem. You can hit second enter really quickly. It'll bring up the previous problem. N equals 12. So I'm just going to go back and change N to 12 for this problem. Close my parenthesis and change this 1 to 12. Might have to retype a few things. Enter, and that's your answer there. That one's 28,274 and 74 cents. All right, so this is the first part of the test review video for logs and exponentials. Check in on the second video if you need help with the second portion of the test review.